Okay, so what I do for these wires, for these moving wires here, is I use the right-hand rule. It's basically, I pretend that I'm a positive charged particle. Now we all know that positive particles don't move on wires, but let's just go with it. Okay, what really happens is electrons go the other way, but that's too confusing. So I pretend I'm a positively charged particle on this wire, right? So basically, if you have a positively charged particle and it's moving this way in a magnetic field that's out of the page, right? Okay, remember this is our index finger, right? The magnetic field is our middle finger, right? Okay, so my index finger is going that way, my middle finger is going that way. My thumb is actually going this way. The magnetic force is down the page, right? So positive charge would, if it could move, would move down the page. In reality, negative charge moves up the wire, but the bottom is still positive because of subtraction. Okay, so the bottom is the positive end. Okay, so let's do this again. Let's go here. It will be a positive charge on this wire, right? We are a positive charge. Always be a force for positive change, right? Okay, so this is my index finger, right? My index finger is down this page. My middle finger is into the page, right? So I do this with my middle finger. This is my middle. And my thumb is to the right. This side here is where the positive charge would go. Of course, negative charge actually drifts that way. Okay? All right, now take a look at these guys here. This is kind of fun. We can do this any of two different ways, right? The notion here is that this is fixed. Whenever you see this is like a standard physics problem. That guy's fixed, this guy moves. So in the next instant, this guy will be here and then here, et cetera, right? Before this, it was here, right? So clearly we are gaining flux out of the page, not because the magnetic field is increasing, okay? Not because the angle is changing, but simply because this area is changing, right? So we are gaining out of the page, right? We're gaining out of the page flux, and so if we gain out of the page flux, the reaction is to oppose, right? So we oppose by creating into the page, right? By making into the page flux. And the way to make into the page flux is to go clockwise in this loop. So we're going to go down that wire that way, right? Clockwise. Okay. Now, incidentally, another way to do this guy, is to say, okay, I'm a positive charge on this wire. If I'm going this way, index finger this way, middle finger out of the page, right? Okay. Index finger there, middle finger out of the page. Positive charge is going to move down. Well, if it moves down, then it moves left, then it moves right, then it moves right, or up and then right. Okay, it's going clockwise. Okay, and then clockwise or anti-clockwise. Well, let's do the classic way, right? We are, in the next instant, we're going to have less of this flux, right? The area is decreasing now, right? So we are losing into the page. And our thing is we replace it. We replace. Okay, so to make flux into the page, of course, you go clockwise in the loop. Okay, so that's way number one. That's the way I would do it. But you can also do it the other way, right? Let's be a positive charge on this wire. If it's positive, I've got my index finger down the page, right? Here's my index finger, right? My middle finger is into the page, right? And my thumb is pointing to the right. So these positive charges would move to the right. Of course, they can't move, but we'll just go with it. And that makes, if it's moving to the right on this stretch, then it's got to go pump clockwise in this loop.